In 11.2, we are talking about, again, solids, okay? But rather than just all types of polyhedrons like we were talking about yesterday, we are talking about a specific type of polyhedron called a prism, okay? A prism, now this first part of the notes are just a lot of vocab, and I apologize for that. But a prism is a polyhedron that has two faces that are congruent and parallel to each other. Okay? It has two faces that are both congruent and parallel to each other. So we call those the bases. And so right down here they have this. This happens to be a pentagonal prism because the bases are pentagons. And so those two bases, this pentagon here and this pentagon down here, those are the bases. They are parallel and congruent. All of the other faces then going around that object, those are called lateral faces. Those are called lateral faces. Now, you do want to pay attention to that because we are going to be finding surface area most of the time, okay, which we'll talk about in a second, but we're also going to be finding lateral area sometimes. And so you need to make sure that you understand what the lateral faces are so that you know what you're going to be finding for your lateral area, okay? So the lateral faces are then the sides, not the bases. Next, in our solids, we need to talk about the altitude of a prism, which is just the height of a prism. And one thing that I disagree with our book on is the variable used for the height of a prism, the height of a solid in general. They use lowercase h. In my opinion, and in other books I've taught out of, it should be a capital H. Okay, so let's make that change right now because I think that kind of makes more sense as we're creating our equations, is that lowercase h is the height of a two-dimensional shape, like the height of a rectangle or the height of a triangle, okay? But if we're talking about a solid, a three-dimensional shape, we're going to use capital H. Okay? And just like height of two-dimensional shapes, the height of a solid still needs to be perpendicular to the base. But this time, the base is not just a line segment. Okay? This time, that height has to be perpendicular to the entire base of the prism. Okay? It's that entire plane for that base. Okay? So then looking at the second one there, the reason that the height is drawn where it is because that happens to be a trapezoidal prism. The bases are trapezoids. So here we have this trapezoid. Over here we have this trapezoid. And so then the perpendicular distance between those two trapezoids is then the height of that particular prism. Making sense? Everybody okay with that? Okay. Well, those are right prisms. Right prisms mean the lateral faces, the lateral sides, are perpendicular to our bases. Okay? What about a different type of prism called an oblique prism? An oblique prism, again, the bases are still parallel. The bases are still parallel. All that's happening now, though, is like it's a stack of cards pushed to the side. Okay? And so now it's leaning to a side, giving us our prism. And so the height, the perpendicular distance between our bases, so this base parallel to this base, that height to be perpendicular would be outside the prism. Or I suppose they could have given it to us as maybe this height here, like we've seen on two-dimensional objects before as well. Okay, but it's always that perpendicular height between our bases. Okay? Questions or comments on that? Nothing yet? So, if we are finding the lateral area, that is going to be just the area of all the lateral faces added together. If you're finding the entire surface area is going to be the area of all the faces that you can touch. And so in this case, I happen to be holding up a pentagonal prism. All right, a pentagonal prism. The base is a pentagon. And of course, I have two of them, top and bottom, right? They're congruent, they're parallel. And so then all of these sides are what shape? rectangles. How many should I have if the top's a pentagon? 5. All right. And so this, all these rectangles added together, is the lateral area. But if I want the surface area, I got to take my lateral area plus my 2 bases. I want the entire surface. Think of it as trying to wrap this with the max or the extreme minimum amount of wrapping paper. I would have a perfectly cut pentagon to put on here, a perfectly cut pentagon to put on there, and of course perfectly cut rectangles to go around the sides. That is what we're trying to find when we find surface area, the total surface area. Okay, cool? Great. All right, so to calculate surface area, you're going to notice I don't give you an equation for this. For prisms, I don't give you an equation. Why? Because we already know them. We already know them. If I hold up a triangular prism, what are the bases? Triangles. Can you find the area of a triangle? Absolutely. 1/2 base times height. What are the lateral faces? Possibly squares. In this particular example, that might be a square, but they're at least rectangles, right? And how do you find the area of rectangles? Base times height. We don't need a specific equation for the surface area of a prism because first off, each prism is going to be slightly different as far as its shape and as far as what bases it has. Okay? And so the equation changes a little bit. What you need to remember about surface area is that it's going to be the sum, adding them up, of all the areas, all the faces. The faces are the things you can touch. Okay? All the faces you can touch. We've got to add them all up. That's our surface area. So let's come down here. They give us a right prism. A right prism. The fact they say it's a right prism is helpful because that means that we have just all right angles here, which tells us positively, without the shadow of a doubt, that each one of these faces is a rectangle, not a parallelogram, not anything different, right? So that's going to be all rectangles. Good. What are we going to consider the base? Okay, you want to say the bottom? That's usually pretty common for people to say it's the bottom. But could I say it's one of the other sides? In this prism, yes. In a rectangular prism, I could. Because all the sides are rectangles. It doesn't matter which rectangle I put in the Play-Doh factory, I'm still going to get a rectangular prism when I create it. Okay? So it doesn't matter if this is the base, or if this is the base, or if this is the base, or whatever. Okay? Unlike with a triangular prism, where it does matter which side I call the base. Okay? The triangle is the only way that can be done by the Play-Doh factory. The square, it can't be made as a Play-Doh factory. So you got to make sure that you're looking at the bases properly. All right. How many surfaces on this shape can we touch?
12. Or no.
6 of them. Let's name them. Bottom. Top. Left. Right. Front. Back. Okay, 1. Are there any congruent shapes? Which ones? Not all of them. Top and bottom would be congruent. Left and right would be congruent. Front and back would be congruent. Okay, so when I'm going through this, I want to try to figure out my surface area formula by actually drawing those different surfaces. So I have 2 rectangles that are 10 by 4. That's the top and the bottom. Everybody see that? Plus, I have 2 rectangles that are 4 by 6. That's going to be my left side and my right side. Does everybody see that? Plus, I have 2 rectangles that are going to be, well, I'm talking about the front and back. What are the front and back dimensions? This front rectangle, let's do that in a different color. This front rectangle has, well, 10 for its base. I can see that. What's its height? It's 10 by 6. Remember, we're dealing with rectangles here. Opposite sides of a rectangle are congruent. And so that vertical height has to be 6. So 10 by 6. All right? I do actually expect to see you guys write that down on your work. Okay, when we're doing surface area, I expect to see you break it into its different surfaces. All right? That's handy because now the next two steps that you're actually getting credit for come easier. We need to write an equation. Surface area is going to be, well, 2 times the area of a rectangle. It's 2 times base times height. Plus 2 times the area of another rectangle. Plus 2 times the area of another rectangle. Okay? Now, I have had students in the past say, well, can't I just add those all up and say that it's 6 times base times height? What do you think of that? No? Why not? It's not a cube. All the faces are not congruent, so they're not all the same base and height. You with me on that? Okay. So now that we have that, we can again look at our little map we made at the top and plug in all of our dimensions. So I have 2 rectangles that are 10 by 4. I have 2 rectangles that are 4 by 6. I have 2 rectangles that are 10 by 6. And now I can go ahead and calculate that. So 2 times 4 is 8, times 10 is 80. 4 times 6 is 24, times 2 is 48. 2 times 6 is 12, times 10 is 120. And so we get 248 square meters as our surface area. Questions? Let's go ahead and do another one. Let's take a look down here. Find the surface area of this right prism. Okay, well, what surfaces do we have? What surfaces can I touch? Triangles and rectangles. Well, how many triangles? 2 triangles. Are they congruent? Yes. And so rather than writing 2 separate triangles, I can just say 2 times one of the triangles. What's the base of the triangle? 8. What's the height? 5. Okay. Plus, what are the sides? Rectangles. Okay, are there any of them congruent?
Yeah, 2.
2 of them? Which ones? Which one are you calling the top one? The one that slants?
Yeah.
Okay, well, isn't this a right triangle? And so isn't the hypotenuse always the longest side of a right triangle? Yeah. So are any of them going to be congruent? No. None of them will be congruent. And so we need to go through and just find the area of 3 separate rectangles. All right, well, let's look at the rectangle that's on the bottom. What's its dimensions? 12 by 8. Look at the rectangle that's on the left side. What's its dimensions? 5 by 12. This side here is 12. That means this side here is also 12. Because that's a rectangle, so therefore it's a 5 by 12 rectangle there on the left side. Okay? And so now we want to find that third rectangle, which is that slanted one. All right, so if I'm looking for this rectangle, I see that one of its sides is 12, so its base is 12. What's its height?
We don't know that.
We don't know that, so we have to find it using the Pythagorean theorem. Absolutely. So 5 squared plus 8 squared equals h squared. All right, so that's 25 plus 64. That's 89. Got to take the square root of both sides to find out what h is. Square root of 89. Does that reduce?
No.
Is it a perfect square?
No.
I don't know. How do we check it? Well, remember, we go ahead and list our perfect squares. And the best way to reduce this down is to take half of this number, so 89 divided by 2, about 45, right? Okay, it's about 45, a little less than 45. And so that number then tells us where to start on our list of perfect squares. I don't need to check all of these, I just got to check the ones smaller than 45. So, does 36 go into 89? Yeah, so no, because it's a decimal, right? Does 25 go into 89? No. Does 16 go into 89? Does 9 go into 89? Does 4 go into 89? So guess what? The square root of 89 is a reduced radical. That is our height. Okay? Now we can go ahead and write our equation. So the surface area is going to be 2 times the area of a triangle, base times height, 1/2 base times height, plus 3 rectangles. So base times height plus base times height plus base times height. And those are 3 different sized rectangles, right? So I can't combine them together. So our surface area is going to equal 2 times 1/2 times the base, which was 8, times the height, which was 5, plus 12 times 8, plus 5 times 12, plus 12 times the square root of 89. Now we can simplify. Well, I see that 2 times 1/2 is just 1. So what's 8 times 5? 40 plus 12 times 8.
96.
Plus 5 times 12.
60.
Plus 12 times the square root of 89.
12 times the square root of 89.
Leave it in simplest radical form. I want to simplify this down. I cannot simplify everything, but I can add those 3 numbers together. Remember, I can't add the 12 to the rest because I have to first multiply by the square root of 89. Okay? Multiplication comes before addition. But I can add those 3 numbers together.
Which gives you 196 plus 12 times 8.
All right, so our surface area is 196 plus 12 square root of 89 square feet. Again, we like exact answers when possible, unless they tell us to find a different type of answer, a rounded answer of some sort. Okay? Questions on that?